All right. My name is Rob Kelso. I'm the Executive Director for the Pacific International Space Center for Exploration Systems in Hawaii. And the first of two presentations today will be to discuss the MoonRiders program, which is a joint federal government, state, and high school program to develop a technology experiment to go to the surface of the moon. So the next chart actually shows the name MoonRiders. Riders meaning research investigating dust expulsion removal systems. And this was a name picked by the Hawaii high school students that are involved in the Lunar Flight Experiment program. This is the logo that the students came up with. It's very interesting. In the top left-hand corner, you see some black balls, and those represent two things. One is the dust that is so critical to this experiment on the surface of the moon, and it also represents the Hawaii island chain. So the big dot closest to the moon actually is Big Island, where PISCES is hosted. PISCES is a state program under the Department of Business, Economic Development, and Tourism. And so we are funded by the state of Hawaii to do planetary surface systems technology development. And that actually includes, in this case, a flight program in dust mitigation for spacecraft systems. On the next slide, dust has been a major issue for us in space. In front of you is the Mars Exploration Rover, one taken from Sol 568, the other one from Sol 1358. And you see that the one on the right, dust is all over the Mars rover on the solar panels, radiator, electronics. And when it does so, it reduces the efficiency of the operation of those systems. It collects less efficient solar power into the photovoltaics. It rejects heat less. And so periodically on Mars, you'll get a dust devil that goes by. It'll clean off those radiators and solar panels, as you see on the left, restoring efficiency. On the moon, we don't have that luxury of having a dust devil with no atmosphere. And dust, as we saw in the Apollo program, as well as in the Mars program, continues to be a big issue in planetary surface systems. Here you see one of the spacesuits from Apollo 17 in December 1972 with dust totally covering both the helmets and the material that the spacesuits are made of. In fact, the dust, we know, is so abrasive that there were small holes generated in the dust. And at the end of the third EVA on Apollo 17, Harrison Schmitt had commented that his visor was so scratched by the abrasive dust that it was almost unseeable through the visor. Coats all over the Lunar rover car that you see on the right, and even optics. Here is one of the camera systems used in Apollo 12, and you can see dust all over the top of the lens, as well as on the glass optics within that lens. So dust and dust mitigation has been a central theme of technology risk reduction for planetary surface systems for some time. So the goal of MoonRiders is to develop, launch, and land and a lunar surface experiment in concert with technology from the NASA Kennedy Space Center, with partnership of both PISCES and two Hawaii high schools, and then use this as a hosted payload on one of the upcoming Google Lunar X Prize launches. And our current time frame for this would be a launch opportunity in late 2016. The demographics of this is extremely interesting. We have academia, we have state presence, federal presence, and then the commercial aerospace sector. From academia and STEM, we have selected two Hawaii high schools, one public high school under the Department of Education, and that's GLXP. That's on the Kona side, the west side of the Big Island of Hawaii. And the other is an independent or private school in Oahu in Honolulu, and that is the Iolani High School. Both of those are terrific schools in robotics, have great facilities for doing robotic operations, and so we have one public and one private school engaged with us in this flight program. At the state level, we have the Pacific International Space Center for Expulsion Systems, PISCES, and then the federal government is represented by NASA Kennedy, and then the commercial private sector is represented by the participants of the Google Lunar X Prize. So the focus here is to establish a joint flight test program that involves 2 high schools in the surface of the moon. I don't know why that happened. And they would actually be building hardware associated with this this flight. And then NASA Kennedy providing the technology associated with the dust mitigation systems. The reason that we're doing this is twofold. One is that dust mitigation technologies are extremely important for planetary surface systems, but NASA's been unable to get it tested at the moon because they're under the current administration, they're not going to the moon, they're going to an asteroid. But through PISCES and the high schools and Google Lunar X Prize, we can help facilitate a technology experiment on the surface of the moon and hence help the NASA Space Agency, in this case Kennedy Space Center, push the technology readiness level from a TRL 4 or 5, which is bench level, up to a flight demonstrated level on the surface of the moon, which is TRL 8 or 9. From a state standpoint here in Hawaii, this is really important because there has, to our knowledge, never been a high school experiment on the surface of the moon. There are many high school experiments on Skylab, on Shuttle, on the International Space Station, but never on the surface of the moon. So this is game-changing and historic in nature. The reason we're doing it within the state of Hawaii is that to promote science, technology, engineering, and math, STEM. Hawaii ranks 46 in 8th grade testing from 2016. So we're using this as a gold standard to help promote interest in students in moving into science, technology, and engineering studies and careers. The breakdown of this, PISCES provides the overall program integration for the flight program. Kennedy provides the technical development, the design development, and then the evaluation of the dust shield. The 2 high schools are building large-scale mock-ups and also are building the frame that the dust shield will sit in, both in engineering tests and for flight to the lunar surface. Then they are integrating those together with camera systems, and we just completed last week, the week of April 16th, or March 16th, large complex tests on Mauna Kea at the PISCES Lunar and Mars Analog Test Site, where we tested the dust shield along with camera systems and mock-up landers in an in-the-field engineering demonstration. And then, of course, the Google Lunar X Prize teams are working with us and providing some engineering systems for lander data configurations, imaging systems, and, of course, eventually they will provide the integration, launch, and landing capabilities for the flight experiment. The dust shield has been in work at Kennedy for a number of years. It originally came out of some work done in Japan, and Kennedy has been maturing those technologies for looking at how to use it to repulse dust off spacesuits, off optical systems, radiators, photovoltaic systems. You see dust covering the electric grid, or what we call the electrodynamic dust shield on the left. And after it's energized at high voltage, low current, it essentially sets up standing waves like throwing a rock into a pond and seeing the ripples. that repulse and eject the dust off of the surface. And so we're looking at this for, again, vehicle systems to include photovoltaics, radiators, spacesuit material, visors, and optics that could be used to rid those systems of invasive dust that impede in performance. The students have been actively involved in constructing the large-scale mock-ups, as you see on the left, the astronautic lander at Iolani and the Earthrise lander at GLXP High School. They have also been involved in doing outreach as a part of this cooperative program with PISCES and NASA, teaching out to intermediate and elementary schools, talking about the flight program and why it's important to be involved in STEM. And they are also involved with mentors and looking at the engineering aspects of the dust shield, the physics of dust, the chemistry of dust, how the dust shield operates, and how it would be integrated into the lander. So they're actually involved in doing engineering prototyping along with PISCES and NASA and readying for flight. This is one of the large half-scale mock-ups of the astronautic lander built by Iolani. You can see the thrusters on it, along with propellant tanks. And down on one of the foot pads, this is the 12-inch foot pad, we plan to integrate the avionics, the dust shield, into this box that has the red stripes on it. And the dust shield fits in a frame compartment on top of the avionics system that will eradicate the dust after landing. So we place it on the foot pad in hopes that during descent and landing, there's enough dust disturbed by the descent propulsion system to land on the glass plate of the EDS, and then we'll take images of that before and after the high voltage operations to determine the effectiveness of the dust shield in repulsing the dust. We just completed a large analog test site. This is in the upper left, the test site in a valley at 9,000 feet on Mauna Kea. And we performed the test site operations, serving as test conductor, test safety officers, and then the students actually performed the engineering development tests at the test site and evaluating various configurations of the EDS as well as various methodologies of camera and imagery to best determine positions for the flight in measuring the effectiveness of the dust shield during the mission. This shows the testing here with the lander associated with a large gantry that we would use to do high-velocity dust tests. Here the test article is moved into the gantry for testing. The gray box on top of the lander is the electronics assembly for the test, providing high voltage and low current system on-ramps that go down to the dust shield that is located on the landing pad in the lower right corner of the image here. This is a propulsive maneuver that we did using high-velocity gas systems that would stream high-velocity gas out of a thruster nozzle on the lander to distribute the extremely fine particles of the basalt dust found at the test site for deposition onto the dust shield. After this dusting, if you will, the lander was lowered and cameras would come around the dust shield to measure the effectiveness of the dust during and after the high voltage operations. Here you see the cameras set up with whiteboards to illustrate the various configuration and imagery that we're taking, and then a mock-up of the Astrobotics Andy rover with camera systems, and it would move up and close to the system to record analysis. Here in the last couple of charts is our here to there for flight. We just completed this large engineering test up on Mauna Kea. From that, the students are doing detailed data analysis of the data that was collected in the test to determine the optimal positions of the dust shield itself as well as camera systems. We hope to do a payload customer contract with a Google Lunar X Prize provider at the end of the summer or early in the fall. We plan to do a second flight verification test of the unit back in Hawaii on the volcano in the spring, or next fall of 2015, in parallel with final flight development of the unit that's ongoing with Kennedy. And then next spring, deliver the flight unit to one of the Google Lunar X providers for a launch to the moon in late 2016. And these last two slides show roughly about 40 students at each of the high schools that are involved with NASA and PISCES in producing this engineering and flight unit for testing duct shield technology for planetary surface systems. So thank you for allowing me to come and share the exciting story of MoonRiders with you today as a part of LSA Cloud.